Power is another term which has a general, everyday use and a specific physics use. In everyday parlance, power means the ability to manipulate a situation, or how strong you are, or how fast you can make a car go. Generally, it means the level of control you can exert over a situation. In physics, it means the rate of change of energy with time. The equation for power is very simple to state. Power equals change in energy divided by change in time. However, it has many disguises depending on which situation you are using power in. In mechanical power, the equation for power is Fs cos theta divided by t, force times by displacement times by the cosine function of the angle between the direction of the force and the direction of motion. In electrical power, the equation is P equals IV. Power is current times voltage. However, in any expression of power, in any branch of physics, it must always whittle down to being energy over time. The unit for power is named after an engineer. The unit of power is the watt. This is an onerous physics teacher joke. Not watt, W-H-A-T, but watt, W-A-T-T. If you have an equation for power and its units are not the watt, then you do not have a power equation. The watt is 1 joule per second. You can also express power as force times velocity of an object. As power is energy divided by time, and energy is force times displacement, we have a situation where power equals force times displacement divided by time. Displacement divided by time is velocity, and so power can be expressed as force multiplied by velocity. Due to all these different expressions of power, we have many different ways of expressing the watt. 1 watt does equal 1 joule per second, but it also equals 1 Newton meter per second. A joule can be expressed as 1 Newton meter, a term more commonly used in discussions of moments from our earlier podcast. A moment is an expression of energy. In order for a system to be balanced, the energy on both sides of the system has to be equal and opposite. In the same way, power can be expressed in terms of how quickly a force is moving. But how do we know how much of the energy we supply to a system is actually useful?